Okay, welcome back, and now we're going to talk about radians. Okay, radians is another unit of measurement used to measure angles, just like degrees. Okay, so what is a radian? So how do we define a radian? Well, a radian is the angle measure between two radii, okay, of a circle, in this case, such that the arc length that's intercepted between the two radii is equal to the same length as the radii. So we have a situation where this section of the circle is bounded by these two radians such that this arc length is equal to the length of the radius. The angle between that, so this angle, the measurement of that angle in this situation is called a radian. Okay? So this is, in this case, would be 1 radian, and it's abbreviated RAD. Okay? So that's the definition of radian. It's the measurement of theta, the measurement of the angle between two radii on a circle such that the arc length of the circle between those two radii is this equal to the length of the radius. Okay? Now, it just so happens that how many of these radians, how many of these can fit all the way around the circle? Well, it turns out it's a little bit more than 3. So 3 and a smidge. Okay? So, in fact, 6 and a smidge. Okay? So, it turns out that 1 radian, okay, so 1 radian, okay, or excuse me, I'm sorry, one revolution, I meant to say. So 1 revolution around the circle, 1 revolution completely around the circle is equal to 2 pi radians. Okay? Which is basically 6 and a smidge, approximately 6.28. Okay? So a little bit more than 6 1/4 times. Okay? So now, how do I develop the conversion factor? What if I want to convert between degrees and radians? So now, because that's an interesting question, right? What if I want to convert from radians to degrees or vice versa? So we know that in 1 revolution, let's see, we know that 1 revolution is also equal to 360 degrees, right? Well, if 1 revolution of a circle is equal to this in radians, and 1 revolution is also equal to this in degrees, well, guess what? By transitivity, these two must be equal then, right? So that means that 360 degrees is equal to 2 pi radians. Okay. Or, if we divide everything by 2, guess what? That also tells us that 180 degrees is equal to pi radians. Now, we could develop another conversion by looking at this here and developing a proportion, right? So, if I know that 1 revolution is 2 pi radians, then I can set up a proportion that says, well, I can say, what is 1 radian? Well, I can say, okay, R divided by 2 pi radians, or R, right? Okay, so 1 revolution, 1 R, which is the radius, divided by 2 pi times R. Remember how many of these radians are in 1 revolution? It's 2 pi. So if I have R, I can divide that by 2 pi times R, because that's going to be 1 revolution. So this is a proportion. What proportion of the circle is r? Okay, well that's going to equal what? Well, in degrees, right? How are we going to get that in degrees? Well, it's going to be theta, right? Theta divided by 360 degrees. So this ratio of radians should be equal to this ratio in degrees, right? Because they measure the same angle, right? It's the same section of the circle. So now if I simplify this, well, this cancels with this. So what do I get? I get 1 over 2 pi radians is equal to theta over 360 degrees. So I can say that, hey, if I look at this, I say 1 radian is equal to what? 2 pi theta over 360 degrees. Right? Okay. Okay, I could do it that way, or I can solve this for theta, and I can say theta, or by the way, this can also equal what? Pi theta over 180 degrees. And then, or I can solve it for theta, and theta can be what? 360 degrees over 2 pi, or 180 over pi, which by the way is approximately equal to 57.3 degrees. Okay? So what is it saying? What is it saying? It's saying 1 radian, okay, is the same as 57.3 degrees. Okay, that's it. We'll do some examples and move on.